Push a small lever, and in about 4 seconds, everything in this bowl simply vanishes. No motor, no pump, no electricity, just water, gravity, and a shape hidden inside the porcelain. It is one of the most used machines on Earth, and almost nobody knows how it actually works. This single object has saved more human lives than almost any invention in history. For most of human history, human waste just went into the street, and disease followed close behind. In 1596, an Englishman named John Harrington built the first flushing toilet for the Queen herself. Everyone laughed at it, and the idea sat nearly forgotten for almost 200 years. Then cities exploded in size, cholera swept through the crowded slums, and thousands died from filthy water. Suddenly, the flushing toilet was not a joke. It was survival, and it quietly reshaped the modern city. So how do we turn a bucket of liquid mud into a glass-hard machine that never rusts and needs no power at all? To understand the flush, you first have to watch one being born. It starts as a recipe, and the recipe is surprisingly ancient. 4 raw ingredients dug straight out of the ground. Kaolin, a soft white clay, gives the body its shape. Ball clay makes it sticky and easy to work. Feldspar is the secret weapon. In the kiln, it melts and glues everything into glass. And ground quartz gives the finished piece its strength. Now, you might ask why we do not simply make toilets out of metal or plastic. Ceramic is cheap, it never corrodes, and while soft it pours into any shape. Nothing else does all 3 at once. Blended with water, these powders become a smooth cream the factory calls slip. It looks like liquid chocolate, but this is the future toilet in liquid form. The slip is poured into giant tanks and blended for hours until it is perfectly smooth. Now comes the clever part, and it relies on a material that behaves like a sponge. The molds are made of plaster, and plaster is thirsty. Liquid slip is pumped into the hollow plaster mold, filling it completely. The dry plaster instantly starts pulling water out of the slip that touches its walls. A solid skin of clay builds up against the mold, growing thicker every minute. After about an hour, the leftover liquid in the middle is simply poured back out. What stays behind is a hollow clay shell in the exact shape of a toilet. This is why a toilet is hollow and why it weighs far less than solid stone. Modern plants speed this up with pressure casting, forcing the slip into the molds under real force. But even the best plaster mold wears out, and after roughly 100 casts, it is retired for good. The mold is opened, and a soft, damp toilet is lifted out by hand. At this stage, it is called greenware, and it is heartbreakingly fragile. A worker sponges away every seam and mold line until the surface is flawless. Then it dries for days slowly. Rush it and the whole piece cracks apart. But the most important part of a toilet is the part you never see. Hidden inside the base is a curved, twisting tube called the trapway. It bends up, over, and back down, like a frozen wave sealed inside the ceramic. That bend always holds a little water, and that water is a plug against the sewer. It is the reason your bathroom does not smell like the pipes beneath the street. Leave a toilet unused for weeks, and that thin water seal slowly evaporates away. And then the smell of the sewer creeps right back up the pipe. That little plug of water is everything. Shaping this hollow curve, sealed inside solid clay, is the hardest trick in the whole process. Get the curve wrong by a few millimeters, and the toilet will never flush properly. Which is why every trapway is designed on a computer and tested obsessively. Now our toilet is shaped, but it is still soft, dull, and completely porous. To become smooth and waterproof, it needs a coat of liquid glass. This coating is called glaze, and it changes everything. Robotic arms spray a fine mist of glaze evenly over every single surface. The glaze is really just powdered glass floating in water. In the heat to come, it will melt into a single, seamless, glassy skin. That skin is why a toilet is so easy to clean and why bacteria cannot soak in. Factories can add any color to the glaze, yet almost everyone still chooses white. White shows dirt instantly. For a machine about hygiene, that is a feature, not a flaw. In most factories, the glaze and the clay are fired together, in one single pass, fusing into one solid body. Now the toilet is ready for the one step that makes it permanent: fire. It is loaded into a kiln, a long tunnel of controlled fire. Inside, the temperature climbs to around 1,200 degrees Celsius. That is hotter than molten lava, held steady for up to a full day. And in that heat, something remarkable happens to the clay. The feldspar melts and flows into every gap, fusing the grains into one glassy solid. This is vitrification, and it is why the material is called vitreous china. The porous mud becomes waterproof and hard enough to last for decades. But fire also shrinks it dramatically. The toilet comes out about 12% smaller than it went in, which is why designers build every mold oversized, planning for the shrink in advance. When it finally cools, each toilet faces a gauntlet of tests. Inspectors run their hands over every inch, hunting for cracks and tiny pinholes. A line is drawn across the surface to check that it has not warped. Because in a kiln that hot, even solid ceramic can sag and twist. Then the real test: does it actually flush? Engineers dump in golf balls, sponges, even weighted dummies, and demand a clean sweep. A good toilet must clear all of it in a single flush every time. But here is something most people never notice. Not all toilets flush the same way. The simplest kind, a washdown, just shoves water in from the rim and pushes the waste out. Cheap, but loud and weak. The siphonic design we are about to see is quieter, stronger, and far more satisfying. Only then is it stamped, boxed, and sent out into the world. But we still have not answered the real question. How does a bowl of water empty itself, with no pump at all? The answer is a 200-year-old trick of physics called the siphon. When the toilet sits still, the water in the bowl is balanced with the water in the trap. Press the lever, and a rush of water pours in from the tank, all at once. The bowl fills faster than the trap can drain, and water climbs over the top of the bend. The moment it spills over that curve, the falling water drags the air out behind it. That creates suction, a partial vacuum, right inside the trapway. You can actually hear the change, as a gentle glugging turns into a deep, decisive pull. And suddenly the toilet is not draining. It is sucking, pulling the whole bowl down with it. That is the siphon. Gravity turned into a vacuum, strong enough to empty the bowl in seconds. To prove a design really works, engineers run a test using a very specific and slightly gross fake waste. The very best toilets can clear more than 1,000 grams of it in a single flush. When the bowl runs low, air breaks the seal and you hear it, that famous gurgle. The siphon collapses, fresh water refills the trap, and the seal is set once again. No electricity, no moving machinery, just a clever curve and the weight of water. The whole machine is the shape. That is the invention. There is one last number that changed everything about the modern toilet. How much water it uses in a single flush. In the 1950s, a single flush could use up to 7 gallons of clean water. Today, by law across much of the world, that number is 1.28 gallons or less. The same clean sweep, using less than a fifth of the water. Engineers reshaped the bend, the rim, and the tank so that weaker flows still trigger a full siphon. Dual flush buttons gave you a simple choice, a little water or a lot. Across a single city, that saves billions of gallons every single year. The Romans built grand public latrines 2,000 years ago, flushed by constantly running water. In Japan, high-tech toilets now warm the seat, wash, dry, and even play music to cover the sound. And yet, this is still not a solved problem for everyone on Earth. Right now, around 2 billion people still live without access to a safe, clean toilet. For them, this simple ceramic machine is not a comfort. It is the line between health and deadly disease. The most ordinary object in your home is also one of the most unequal on the entire planet. So the next time you press that lever, look a little closer. You are holding an ancient ceramic, shaped by a sponge and hardened by fire. Run by a vacuum you cannot see, through a curve you will never touch. The humblest object in your home is quietly one of the most perfect machines ever built. From a lump of wet clay to a silent vacuum engine hiding in plain sight. Simple to use, anything but simple to make.